Good morning to all. Welcome to my video lecture on chemical engineering. I am Sri MOHANTA, lecturer in chemical engineering. Today we will study about yet another chapter, that is in mechanical operation subject. That will be the size reduction of equipment, which is the ball mill. Now, what is a ball mill? If I if I tell you about the ball mill, then ball mill is a mill which is used for the size reduction from larger particle to smaller particle. There are different kind of ball mills are there. Generally, it consists of one cylinder, that is called cell, and inside which solid balls will be placed and it will be rotated. Along with the materials will be also placed with the balls. So when it will be rotated, the balls will go up and they will start falling. So when they falls on the materials, and so that there will be impact will happen and hence the size reduction happens. So let us study in detail what happens. Moving to the next page. A definition of ball mill. Right. Then it is a type of grinder used to blend materials. Either it is used to blend materials. Example, in mineral dressing process, or I can say in paint also, in paint industry or in ceramic industry, etc. Now here it is I written for the blending of the materials. Apart from blending, it is used for size reduction also. Now it works on the principle of impact. Remember this word, impact, and also by attrition. Now what is impact? Impact is, as I told in my previous lecture also, the impact is nothing but applying of force for a very small time. That is called impact. For example, hammer. Next, attrition. What is attrition? It is like rubbing action on the surface. So that is my attrition. So it works on the principle majorly on the impact and less on the attrition. Now, how it looks like? If I show you how it looks like, look at this. This is a construction. How it looks like. So as you can see, this is a side view of it. So this is a cylindrical drum. If you look it from its left side or left view or right view, it looks like this. As you can see, this is its left view. So this is a circular one, mounted with some shaft and with ball bearings. As you can see in the ball bearings. These are the ball bearings. This side is fitted with a motor. This is fitted with a motor so that it will rotate this cylinder in this way. Now as you can see, this is something which is called closure or cover. Now in the cylinder there should be one opening in which we will put the balls. These are the balls. As you can see, the round things are balls, and these are the materials which you need to crush. So along with the balls, the materials are also filled through this cover. After filling, this cover will be closed using nuts and bolts. Now this is a cylindrical cell, as I already mentioned. This is a gear. This is fitted to motor. Now there is some clearance from the ground, and these are the support pillars in which it can rotate. As you can see in the below picture, which is a side view, left or right, through which you can see. Now sometimes this can be little bit modified, like hoppers are also there through which you can put the materials, but generally the top figure, this figure is used, this things are used. Now working, this is a construction, as you can see. Now I'll go for the working of it. In the working, what happens, as I already told you, this the a gear first rotates the before gear the materials are placed, the materials and balls are put inside the cell. Cell is nothing but the cylindrical cell. Next, the mouth is then covered, or here mouth is covered. This is a mouth or cover. As you can see, these are the mouth or cover. So this is mouth is covered by nuts and bolts tightly. Why tightly? Otherwise, when the balls will fall on this, when the mouth will go to the bottom side, the balls will fall from the top, then this may get open and the materials will come out. So the mouth is covered by nuts and bolts tightly. Next, the cell is rotated by electrical motors. This is its working. After that, what happens? Now we'll go into the what happens when this working has been started. Now if we go little bit on the next page, we can see, suppose the cell started rotating. So what happens on the very first position? As you can see, this is rotated up to certain angle. So at the certain angle, the balls will also try to rotate along with the cell or cylindrical cell, or we can say here it is a mixing is happening. Now when the cell rotated little bit upper, then what will happen? They will start sliding bottom towards the bottom, or this is called water flow. This is called water flow pattern. Now when it is rotated little bit more up, or it's little bit more velocity, then what will happen? It will go and try to fall in this direction. So this is nothing but when we increase the speed of that cell, how this behaves, this is given. The first is the low speed, it will behave like a mixed pattern. So it will be only mixing with the materials, the balls will mix with the materials. If we further increase the speed of the cell, then what will happen? It will go and fall, which is my waterfall pattern. Now if we increase more and more speed, then what will happen? It will go to the top and fall. Now which one is desired out of these three? Out of these three patterns, we need the most the third pattern, which is your operating mode of ball mill. Now what will happen in the second pattern? In the second pattern, what will happen? It will also work, but look at the height. In the second, it is falling from this level, and in the third, it is falling from the top level. So definitely when it falls from the top level, the kinetic energy or the potential energy will be more at the top, and it convert into kinetic energy, and it will fall into up to almost like a diametrical height. So it will give a more impact on the materials. So we want our we want the ball mill to be in this condition, not the first and second. Now what will happen? Here it is not mentioned. What will happen when we increase further speed? So when we increase the speed further and further, then what will happen? Any guess? So when we increase it, then what will happen? The balls will not fall. They will behave as stagnant. Now that is called critical speed. So beyond critical speed, if you operate, then the ball will not flow. Alright. Now, what is a critical speed? We will find out. So, okay, here also one thing is given. As you can see, if you rotate the speed, this is the first case. When we speed will be a little bit less, then it will rise up to this position and it will start mixing with them. Now when we further increase, it will further increase the speed, then they will go and fall from here. If we further increase, then what will happen? They will not fall, they will be behave like they will be stick to the wall of the cell. Now, how to find out the critical speed of that mill? So at this particular velocity will be called as critical speed of the ball mill. Now, we will derive the critical speed of the ball mill. Critical speed of the ball mill. What is the critical speed? The speed at which the balls, the materials will never fall, so there will be not any kind of impact will happen. So that is called the critical speed. Now let's assume the balls are rotating at critical speed. So we will take, this is my cell. So this is the ball, this is the center. Now what will happen? The cell is rotating on from left to right, let's say the speed, angular speed of omega. Now this is my radial height. The capital R is nothing but a radius of the cell. Radius of the cell. Now this is a small r. What is a small r? The small r is nothing but, you can write, small r is nothing but radius of the balls. Now when this ball is at the top, it will experience two forces. So what are these two forces? One is the upward forces, which is due to, which is the upward looking force, that will be due to centrifugal force. So I will write it's Fc, and the bottomward force, that will be due to the gravitational force, Fg. Now at the critical speed, what happens? These two forces will counterbalance each other. So when they counterbalance each other, what happens? The ball will, when the force will be balanced, then there will be no net movement of the ball. So at the critical condition, we can write at critical speed of the ball, at critical speed of the ball mill, the net force will be 0. So net force, what are the forces are acting here? One is centrifugal force and another one is by gravitational force, which is nothing but the weight, or we can say the weight of the ball is balanced by the centrifugal force, So we can write Fg equal to Fc, which is nothing but force due to gravitation or weight will be counterbalanced by the centrifugal force. Now as we know, Fg is nothing but gravitational force is nothing but mass into acceleration due to gravity, mg, which is equal to, and what is the centrifugal force? That will be mass into radius into omega square. Now what is the radius? If we observe, a lot of people do this mistake here. What is the radius? It's not the capital R, not the small r, but the radius up to the, from the center from the center to the center of the ball, which is nothing but capital R minus small r. So this into omega square. So these are the force due to gravity and force due to centrifugal force are balanced. So we can cancel the mass from both the side, and we can write omega into r minus small r is equal to g, nothing but I have just taken the right hand side into left hand side, left into right hand side. So if we find out omega, this is equal to then g by under root of g by capital R minus small r square root. So we know this omega is nothing but this is equal to 2 into pi into n. What is n? N is nothing but revolution or rotation per second. So this is the angular speed or rotation per second, RPS, which is called. Remember, this is RPS, not RPM. You have to convert the RPS into RPM. What do you have to do? You have to multiply by 60. So I can say RPM is equal to 60 into RPS. So this is the formula, because 1 minute is equal to 60 seconds. So you have to multiply 60. So we can tell, if you replace this omega by 2 pi n in this particular equation, so it will be like 2 into pi into capital N, this is equal to under root of g by r minus r small r. So we can write n equal to 1 by 2 pi under root of g by capital R minus small r. So this is the speed. Now we derived this at which condition? It is in the critical condition. So we can write as NC. So NC is nothing but the critical speed of ball mill. Critical speed of ball mill. Now we can convert it if the generally the diameter of the balls and diameter of the cells are given. So we can always replace this radius into diameter. So we can write NC is equal to 1 by 2 pi into under root of g divided by, if you write this radius as a diameter, so we can put diameter by 2 minus small diameter by 2, or else we can write it as critical speed equal to 1 by 2 pi under root of 2 into g by capital D minus small d. So this is the critical speed of the ball mill. So if you operate the ball mill beyond this speed, then the balls will never fall and there will be no impact will happen and there will be no size reduction will happen. Now if you solve one example, it is given, let's say, find the critical speed of a ball mill which is rotating at 100 rpm, which is rotating not 100 rpm, find the ball mill which has diameter of the cell is 100 millimeter, 100 centimeter, not millimeter, and diameter of the balls are 10 centimeter. Now how to solve it? Nothing but we have given capital D is given as 100 centimeter. Convert it into meter. This is nothing but 1 meter. Similarly, diameter of the ball small d is given 10 centimeter, which is nothing but 0.1 meter. Now put everything here in the above formula. NC is nothing but 1 by 2 pi. Now under root 2 into G value is 9.81 meter per second square, and you have to put here 1 meter minus 0.1 meter. So how much it gives? NC is equal to 1 by 2 pi and under root of 2 into 9.80 by 0.9. If you calculate, then we will get the value of NC. Now if we calculate by using calculator, I am doing it. Calculator 1 by 2 pi nothing but 6369 into under root of 2 multiplied by 9.8 this value comes to be 4.667. So NC equal to 2.94 RPS. So this is equal to 2.94 revolutions or rotation per second. So how much it is? If you calculate per minute, then how much it will be? You have to multiply by 60. So if you multiply by 60, then how much it is? 176.4 RPM, which is nothing but close to 176 RPM. So if you are rotating it beyond 176 RPM, then the balls will never fall down and there will be no impact will happen, so there will be no size reduction. So this is a very important thing in ball mill. So which we have discussed about this. Now what are the uses of ball mill? The ball mill uses are, I'll tell uses of ball mill. Uses already I have discussed. Anyway, again I will discuss. Uses are application of ball mill. Ball mill. This is widely used in coal processing, color pigments, pottery. In this industry they are widely used. Now it can be done by either wet grinding or dry grinding. Next, blending of explosives. Blending of explosives can be done in this mill. Why it is required? Because the explosives need to be done in a confined place where there will be explosion will happen, then nothing damage should happen. As the ball mill is a confined place, so when there will be any explosion or anything will happen, then also it will be inside the cell only it will happen, so nothing is going to be harmed. Next, it is it has shown effective grinding or mixing for amorphous material. So these are the uses and applications. Now if we go further, the varieties of ball mill. So there are a lot of varieties of ball mill. Like as we said, on whatever we discussed, we have discussed only one kind of, that is a cylindrical cell will be there. It will be mounted from the both sides. Now there will be some varieties will be there. What we can do? We can make a conical one like this, which is 30°, which is 60°. Oh, I am very bad at the art. So this kind of mills are also used. Somehow it is little bit angled one, so that what happens, the materials will be fed from here. It will then it is rotating, so the balls will fall down, and the impact will happen, and there will be a sieve will be there, which will only filter out the required size of the product through the exit. And here there will be feed will be there, and this will be driven by a motor, gearbox and a motor. So this is one of the variety in which it can be used in a continuous manner. So from here feed will be there, it will be little bit inclined one here. So the whatever the impact will happen inside this mill will happen, and the product will be finally taken out from the other end of the mill through a sieve. In this sieve, the oversized material will be placed back again into the grinding section, and the undersized material will be taken out from the outside. So these are the varieties of ball mill. Hope you like this video. Thank you so much. Bye bye and take care. We'll meet again in the next video. Bye bye from YK MOHANTA. Thank you so much.